Good afternoon. My name is Wael Mukhtar. I'm the Director of School of Engineering. It's my pleasure and honor to officially start the Order of Engineering ceremony. The Order of Engineering ceremony have been our tradition for, I would say, 15, 20 years now, Paul, maybe more than that? 25 years, 25 years. I was young, so I didn't. So, what is the Order of Engineering? Why we have to come and celebrate? It's not the usual graduation. They are not wearing the graduation hat. I'm not wearing the graduation hat. And we're not giving diplomas. So what is it? And why everybody who is an engineer on the floor here has a ring like this one in his hand? This is not a graduation party. Today, I'm not a professor talking to them. I'm an engineer who happened to graduate before you. And we have this connection together as engineers. So instead of saying goodbye for graduates, we're saying welcome, fellow engineers. So what does it mean, a ring in a right hand? If you are right-handed or left-handed, this is a working hand, by the way, it could be right or left. Why I use my right hand more? I'm right-handed. Why I write with it? And I do more work with it. As an engineer, I use a lot of tools with my right hand because it's stronger and has more skills. And these skills are serving me and give it favor. So that's why I favor that. And this is why we have that ring to say this is the serving hand, because it's skilled. So on the other side of the room here, these are the service skilled engineers. That this is a time to welcome you to the engineering world, because the rest of us need you. The rest of us need you to be the working hand. That we have been growing, you have been growing for so many years, and we contributed in the last 4 or 5 years. So that this hand has the skills that we can rely on and can use the tool correctly and can help the rest of us. This hand is well prepared, and today we're going to say we are ready for it. We're going to stand here as a group and say we have got through the training and this is our turn. This is our turn to take everybody to the next step. Over the last 30, 40 years, engineering role in society have been growing and growing and growing. Smartphones in your pocket now. Cars that can park itself. Houses become a computer now, right? I can control everything. Cars becoming more computers. We have more electronic devices at home that sometimes a coffee machine for me, I maybe use 10% of it because it's too smart for me. Too many options. These are all engineering. This morning I was talking to the engineers, our graduating fellow engineers, saying engineering is an applied creative application of principles. So you think about an idea, they will make it happen. You think about a device that can connect to the internet, make a call, and have video conference. Somebody invented that already. You think about a car that does not have a driver. It's already on the road. You think about somebody reaching the moon. We have minds here that can do that and build it. Principles and applications. All of that are nice. Today we're going to celebrate their commitment to be the working hand and the celebrating hand. So this is a different type of celebration, and we'll be happy to have today 143 new engineers to be added to the line. Every one of them very, very skilled, prepared, ready to go, very well tested, I know, so we know that. You have seen the senior projects in the morning, and we are very proud of this, we call it product, that we are very proud of this product, that I'll see them in 10 years, 15 years, very proudly saying, yes, we had the chance one day to contribute to this skilled hand that's helping and designing the future. So we have a nice program for you today. With my introduction, I know engineers are not good in introduction, but I try to make it. I have the pleasure to welcome the president of Grand Valley State University to say a few words.
Thank you very much, Dr. Mokhtar, and thank you to Dean Platowski for always inviting me to the ceremony today. I find it an incredibly special event. You know, I have had a lot of friends and colleagues. I've always worked at universities with an engineering program, and they've told me through the years that there are two types of people: engineers, all of you who are going to get the ring, and ones who want to be engineers. And so I consider myself in the latter category, and therefore I think maybe someday, if I come to enough of the ceremonies, I'll get an honorary ring to join all of you on this very, very proud day. And you should feel incredibly proud of the accomplishments. You are not sitting in this room as students. You are sitting in this room as new colleagues. And that's just an exciting moment to make that transition mentally and think about your contributions individually. And before I say a few more words to you, new colleagues, I'd like to speak to the faculty and the administration of the college, because I find this particular college to be a leader in our university in the thinking of the integration of experience and the theoretical in academic pursuit, and incredibly creative. You know, one of the things I was reading as I was preparing for this today and thinking about, you know, what is engineering today as so many of the shifts you talked about is occurring? You know, just it is so fundamental. And why is it so fundamental? It's fundamental because it is at its core the integration of theory and practice. It is at its core systemic thinking, and it is at its core a basis for innovation. So of course this college is incredibly innovative, always ready to think about the challenges. And I think of last year. You know, some of us were in this room last year in the middle of the pandemic and with an inability to put more than 10 people in the room. And so many things were going virtual. And I came to this ceremony and they had figured out, the college, you know, how to put 10 people in the room, use every room in the building, have families who were participating virtually, so everything was at 10, so that experience could be an experience that this class would have. And I just think that's emblematic of who this college is and the community that you've joined, both engineering and as Lakers for a lifetime. So I just want to be among the first to congratulate you for your wise selection of Grand Valley State University and for your wise selection in your field. And I'd like you to think about the contributions you're going to make, not only in your field, but in your life, in your family, in your communities, because the work of the integration of theory and practice for new knowledge, the work of innovation, is the work we need to do to lead us into the future. So thank you so much for inviting me, and congratulations to each of you.
Thank you very much, President Mantella. It's a pleasure to have you here. And President Mantella speaks our language. And we'll get you a ring, so very soon. So let me introduce a keynote speaker. Of course, he's an engineer, so it's not a surprise. American Center of Mobility is a center in Detroit. He will tell you a little bit about it. It's not his topic, but he is the CEO and president of American Center of Mobility. In the example I mentioned earlier about self-driving cars, these are the people that testing and developing these cars. I have been in one of these cars. I've been an engineer for so many years. But sitting in a car that does not have a steering wheel, really, there is no steering wheel, was scary, I have to say. But it went through, it can see, it saw the traffic light, it did all it can do. We have a bird flying that was not planned, so the car shook a little bit, but other than that, everything was fine. So I was just about to grab the imaginary steering wheel to control the car. So the keynote speaker is engineer Ruben Sarkar. He is the CEO and president of American Center of Mobility, ACM. He had maybe more than 2 decades of engineering work. Very impressive resume, very long. I'm not going to read it, so I'm going to pick some, and I told him, and he's fine with that. So among the positions he held, he was the Deputy Assistant Secretary of Transportation in the U.S. Department of Energy, the Office of Energy Efficiency and Renewable Energy. Engineers very familiar with these terms, but I'll give you something that may be easy to. His research office was managing $1.8 billion with a B, of research annually. So this is how much you research. You're talking about the future of transportation, self-driving cars and other. He was one of these agency taking care of that. Before that, he worked in other places for R&D. He was a lead manufacturer, electrical engineer for buses, and he worked for GM for almost another 10 years or so. He was one of the developing engineers in the very first 30-foot all-electrical bus. I don't think it's on the road yet, but he was one of the engineers. So he had the chance, his degrees in chemical engineering, undergrad and master's, and he has a long career of the future. You're talking about energy, self-driving cars. He's now working on that. And strategically, I invited him to be the keynote speaker because we're working on a partnership as well. So I know you missed this one, maybe next students, so you're gone. I'm just kidding. So opportunity will be for our students and alumni for future opportunity with him. With that, please welcome Ruben Sarkar as key speaker.
Thank you for the introduction, and I'm really pleased to be here in person. It's been over a year since I've really been in a room with people in 3D and not just their digital twins on a computer screen, so very pleased to have everybody here in person. And I'm not here to talk to you about necessarily the future of driving or cars, but about the journey that 143 of you are about to depart on, namely your careers. A career in engineering is more than just a series of jobs that line a resume. It is a series of choices that lead to the stories about the challenges that we face and overcome, the accomplishments that we remember most with pride, and the occasional failures and what we did to learn from them and move on. For many of you, it will also be about the amazing feats of engineering that will leave your lasting mark on the world. I am at the midpoint of my career, equidistant from the start and the end, and I hope there are still many stories yet to be told that are worthy of the annals of engineering. I'm honored to be able to reflect on those 20 years and to share with you some of the lessons that I have learned and the stories that may help you live up to the pledge that you are taking today. But before I share some of those personal anecdotes, I wanted to share with you 3 inevitable truths of engineering that I found during my career. The first is that you will face pressure and be challenged to make choices that conflict with the pledge that you are taking today, and it will be ever present during your career. The second is that virtually nothing will ever go to plan, things are gonna break, and it's gonna be your job to fix them. And thirdly, to push the bounds of innovation through engineering, you're going to need to take calculated risks, even in the face of significant ambiguity, when things are not clear and when you're unsure of the outcome and unsure of yourself. These inevitable truths are sometimes at odds with one another, as well as the pledge that you're taking. How do you act with integrity when there's uncertainty? How do you avoid risk by taking risk at the same time? How do you serve the public good when doing so could put the public at risk? Early in my career, I was assigned as an expert to a program to use a new material that was projected to save my company tens of millions of dollars a year. A number of my colleagues stood to get big promotions if the project was approved. The company's leadership was also very motivated to see this project go forward due to the large cost savings that they would achieve. I was the lead materials engineer on the program, and it was my signature that was required to approve the project. However, that material being proposed was from a class of materials that had a known history of performance issues and the potential to even cause safety issues in our products. As the expert, I knew I couldn't just rubber stamp the project, but at the same time, I couldn't patently reject it without objectively testing and validating the results. So I proposed a full program to evaluate whether we could use the material, and reluctantly, the team agreed to run a test program to see how that material performed. However, when conflicting results started to come in, some of them indicating that the historical problems were with this material, some of them showing no problems, I started to see a cognitive bias emerge with the group that said, let's disregard the failing results and let's only report the successful results. They wanted to make a decision solely on the passing results. I was put under tremendous pressure to sign off on the project. And at the guidance of my manager, who later became my mentor, and I encourage you to find a mentor, I opted to hold firm. I had to reflect on my choices and whether or not I had operated with integrity, whether I was being fact-based and honest, and whether I was applying my skills to solving the problems. And in each case, the answer was yes. In the end, a consequence of a wrong decision could lead to a safety issue with a customer, and my name was on the dotted line. I was told by a senior company leader that my career may have just ended before it even started. And it shocked me that what I thought was doing the right thing could cost me my job. I was truly afraid that I had damaged my career. But again, I reflected on my decision-making and the choices that I made, and on the advice from my manager and mentor, I decided to hold firm. The pressure kept coming, and it seemed as though the project would move forward despite my individual opposing voice. So I, along with a handful of experts who shared similar views of the project results, made the difficult and perhaps controversial choice to draft a letter documenting the concerns, and we sent it to executive leadership. It was not initially well received by the company executives. However, they could not ignore the panel of expert opinions, and they decided to put the program on hold and search for a better solution. Now, as a side note, and I hope you never have to draft a letter in any capacity, but always seek the guidance of a trusted mentor and seek the counsel of other experts before you ever do, and make sure you're on solid ground. So people were upset for a little while, but the company went back to the drawing board. They developed a new solution that addressed those historic problems. The company saved its money, and people got their promotions. It took a little extra time, but we had the peace of mind with the choice that we made. I wish I could say this was a one-off experience, but this type of situation happens regularly in companies, even with companies and colleagues who have the best intentions. In your career as an engineer, you will face pressure to release products that are not designed, tested, or manufactured to the right standards. There may be pressure to cut costs by taking shortcuts, and there will always be urgent, looming customer deadlines hanging over your shoulder. The choices will not always be black and white. Companies do have to make tough choices, and in some cases, they have to move forward where there's a high degree of uncertainty. Nothing is ever free from risk. However, when there is doubt or your internal compass says something is off course, go back to your pledge, reflect, and ask, was there integrity in the process? Were the standards upheld? Were things objective, fact-based, and honest? Did you apply your skill and the knowledge appropriately to the utmost? Always be mindful and vigilant when people explain away failures and only report the successes. Now, the role of an engineer is not just to prevent mistakes from happening, to flag problems, or to stand against change. Far from it. An engineer's role is to manage change by finding solutions to tough problems that stand in the way of progress. Now, I mentioned earlier a second inevitable truth, namely that nothing ever goes to plan. There's a saying that no plan survives first contact with the enemy. Your preparedness and adaptability to deal with rapidly changing situations is more important than your ability to predict the future or develop a perfect plan. A good engineer has an arsenal of contingency plans. However, a great engineering leader builds confidence that they can lead others to find the right outcomes. Now, when I look back at my career, it was built on a pile of broken parts. Twisted metal, fatigued welds, fractured shafts, leaking pumps, burned clutches, and occasionally a blown-up transmission. Products are often engineered to the edge of performance, and that means eking out every little bit of performance means pushing things sometimes beyond their limits. If you haven't squeezed every ounce of performance out of your product, your competition will. But living on the edge of performance means that every little change can lead to trade-offs and challenges. If you aren't breaking something or at least failing occasionally, you aren't pushing the bounds. And that's not to say your goal is to break things, but the aim of engineering is to push the bounds of performance and to expand the innovation frontier by dealing with those trade-offs and finding solutions. During my career, I have seen many things break. I have had many head-scratching moments where I couldn't figure out what happened, and many sleepless nights looking at things that I did not think could be fixed. Engineers must be resilient and be able to bounce back when things don't go to plan. People who work towards a higher order or a purpose are more resilient in the face of setbacks. The order of the engineer says, when needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and infidelity to my profession, I shall give the utmost. As I said earlier, failure is inevitable, and yet what do you do when you're trying to solve something for the public good and failure is not an option? Working towards a higher purpose will enable you to bring that mental fortitude, that stick-to-itiveness that'll help you solve problems that matter for the world. Some problems take months, years, and even decades to solve. Your pledge brings with it the obligation to serve humanity by making the best use of Earth's precious resources and wealth. From my time at the U.S. Department of Energy, there were colleagues of mine who worked for decades committing their entire career to solving a singular, meaningful problem related to our Earth's resources. They never wavered over countless setbacks or changing political winds. They gave their utmost. Now, the third engineering truth is that you will need to take calculated risks, often in the face of significant ambiguity, when things are not clear and when you are unsure of the outcome or yourselves. Engineers often by nature want things to be done properly and precisely, ensuring that all the contingencies are covered and all the risks of failure are statistically zero. Yet if everything is engineered to the edge of performance, how do you move the needle without risk? Well, in some cases, you can't. When I worked at General Motors more than a decade ago, GM was known to be a very risk-averse company. The culture, like many long-standing companies, was biased towards avoiding making mistakes rather than taking big chances. Toyota had struck a chord with customers with their Prius hybrid, and it was costing GM in the marketplace. They knew they needed to change not just their products, but their culture. I was the lead engineer on the first-generation Chevy Volt electric drive unit, and we were given 18 months to take it from a clean sheet piece of paper design to a production-ready product for a company like GM, who historically developed products over, say, 5 or 7 years. That was lightning fast. And the drive unit needed to contain entirely new components and systems that had never been designed or manufactured by the company before. GM had a process of categorizing risks when any new component or system was being engineered for a product based on the ability to engineer or manufacture something using historical best practices, which in many cases did not exist for this entirely new technology. And based on that rating system, dozens of the systems in the Chevy Volt were labeled as high-risk deviations from our normal practice. Some of the most experienced engineering experts said, if we can't do things the way we've always done them, well, then we shouldn't do them at all. And yet we had no choice. GM was late to the game on hybrids, and the writing was on the wall for an increasingly electrified transportation future. Public good as well as commercial viability dictated that we had to take the risk. We had to differentiate and separate what was unnecessary risk from necessary risks. If we could do things the tried and true way, well, then we should. However, if you couldn't achieve the right outcomes the way you've always done them, it's okay and often necessary to step out of your comfort zone and to take calculated and managed risks and to systematically manage and retire those risks. In 18 months on the Volt, we took dozens of high-risk engineering efforts through adaptive and collaborative problem solving, stick-to-itiveness, and a do-what-it-takes attitude. And we were able to develop and implement many game-changing technologies that serve as the basis for the electric vehicle market today. In engineering, risk management often means knowledge creation by taking necessary risks and putting them to bed through disciplined engineering. During those 18 months on the Chevy Volt program, we operated like a new company within an older company, shifting the culture to one that could take calculated risks for a higher purpose. Your duty as an engineer is to enable change with integrity. It's to be a dynamic problem solver, and it's to take necessary and calculated risks for the greater good of the public and as stewards of our Earth's precious resources. You are at the very beginning of your career, and as I said when I started, your careers will not be a series of jobs on a resume. They will be a series of choices that lead to the stories that you tell, as well as the stories that others tell about you. The Order of the Engineer Pledge embodies within its very short and elegantly stated form a timeless guidance on those very choices that we must make. It will help provide that inner compass which will allow you to navigate uncertainty, to make decisions with integrity, and to bring your skills and knowledge to chart new waters for the betterment of the public and as stewards of our Earth's precious resources. Take pride in your profession as an engineer. Own your own personal story. Amaze the world with your feats of engineering. I wish you great success on your journey. Thank you.
So I have to tell you that Ruben drove 2.5 hours, including half hours getting lost in downtown Grand Rapids, so to come today. And he just came directly to the building here. So really appreciate driving all the way and most probably working beginning of the day as well. So thank you very much for the wise words. We're going to start the order of engineering. Every one of us has one of these you can follow. So each faculty on the stage is going to read his part and follow, and then we'll do the other ceremony. So.
The term engineer first entered common usage for the more successful builders and artisans late in the 18th century when the Industrial Revolution began. It was only after the Renaissance of knowledge, beginning in the 14th century, that a scientific foundation was established to replace the trial and error methods of earlier engineering practices. One of the earliest definitions of engineering was developed by Thomas Treadgold, a famous engineer, architect, and writer, shortly after the Institute of Civil Engineers, or ICE, of Great Britain was formed in 1818. His definition, the art of directing the great forces of power in nature for the use and convenience of man, was adopted and appears in all ICE publications. Professor Hardcross, in a book of his talks entitled Engineers and Ivory Towers, noted that the use and convenience of man are not always identical. Engineering does not tell men what they should want or why they want it. Rather, it recognizes a need and tries to meet it. Thus, Watt saw the need for steam engines, and Bell the need for telephones. Innovation and service are essential components of engineering practice. It is a creative, purposeful, and evolutionary profession. Its practice involves the application of immutable physical laws that can never be violated without penalty.
The professional purpose of engineering involves the pursuit of a learned art in the spirit of public service. By following the precepts of the obligation accepted in public gatherings such as this, the individual engineer reinforces similar efforts of his or her peers, realizing that in unity there is strength. Decades ago, our engineering counterparts in Canada had this same feeling. They believed that a need existed for the introduction of a spirit of brotherhood and cohesiveness among engineers. They believed that a good way to achieve this purpose would be to instill a consciousness of belonging to one another, to themselves as individuals, and to those whom they served. Thus was brought into being in 1926 in Canada what is now known as the ritual of the calling of an engineer. The words of the ritual were written by the English author Rudyard Kipling, who had strong feelings for engineers as the builders of things intended to benefit mankind. In 1953, correspondence began between the Canadian wardens for the calling of an engineer and the officers of the Ohio Society of Professional Engineers, with a view to extending the Canadian ceremony to the United States. Dean Burrell Bush of Cleveland State University designed and held the first ring ceremony on June 4th, 1970. 170 engineering seniors and engineering faculty members took part in this first ceremony. Such is the story of the creation of the Order of the Engineer in the United States. It is patterned on the Canadian concept, but with differences which are distinctly ours, with a stainless steel ring symbolizing the strength and unity of the profession and publicly identifying an engineer. It is difficult to visualize any better symbolism than the continuity of a ring worn for all to see. It says that here is an engineer with a publicly avowed obligation to his or her profession and to those it serves.
Thank you. The significance of the order and the ring. The Order of the Engineer, to which we will soon belong, is an independent movement. The purpose is to foster a feeling of pride and dedication to our profession. The order is symbolized by acceptance of an obligation and the wearing of a stainless steel ring on the little finger of the working hand. There are no meetings other than this ceremony, and there are no dues. We have to accept and interpret the meaning of this ceremony seriously and with deep pride. The obligation, which is taken from the words of the engineer's creed, should be freely given and responsibility gladly accepted. The similar obligation is the engineer's ring. It says to all who see it, here's an engineer possessed of a publicly avowed dedication to his or her profession and the public it serves. It's a badge of recognition which is known to the public. It will be worn with pride and viewed with honor.
Will the candidates for induction into the Order of the Engineer please stand? Will all current members of the Order of Engineers please stand? Your membership in the Order is symbolized by the acceptance of an obligation and the wearing of a stainless steel ring on the little finger of your working hand. There are no meetings other than this ceremony, and there are no other dues. So if you would turn to page 7 of your books, please raise your right hand and recite with me the obligation of an engineer. I am an engineer. In my profession, I take deep pride. To it, I owe solemn obligations. As an engineer, I pledge to practice integrity and fair dealing, tolerance and respect, and to uphold devotion to the standards and the dignity of my profession, conscious always that my skill carries with it the obligation to serve humanity by making the best use of the earth's precious wealth. As an engineer, I shall participate in none but honest enterprises. When needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and in fidelity to my profession, I shall give my utmost. You may be seated. Now, in the presence of your fellow engineers, your family, and friends, you will be called forward to sign your certificate and receive your ring as an induction or an indication of your acceptance of the obligation of the Order of the Engineer. You will then place your working hand through the ceremonial ring and receive your ring as the outward sign of your profession. I will call each of you forward if you would come up to the table to where Dr. Pung is and receive your ring. Jake Adams.
I was expecting more than that.
Logan Anderson Borton. Jacob Arns. Katie Armstrong. Parents and family friends, if you would like to take photos, please feel free to do so. Mitchell Armstrong. Bilgun Batar. Chad Baker. Colin Barnhart. Walker Bars. Evan Bauer. Nicholas Behrens. Nicholas Bernhardt. Austin Blumenthal. Deidre Bortman. Lindsay Bohr. Timothy Boot. Jeremy Bottoms. Corbin Bremer. Chadwick Brown. Matthew Brown. David Bump. Sorry, David Bump. David Boots. Jacob Cartwright. Maxwell Chumley. Daniel Conley. Mason Convertini. Austin Cordis. Kat Constantino. Richard Critlow. Dakota Culbertson. Zachary Cuddle. Thomas Seawalk. Tanner Doggan. Brandon DeFore. Jacob DeSutter. Brendan DeVries. Charlie Dorn. Cameron Deuce. Adam Duke. Logan Dykstra. George Ebling. Paul Eggerding. Drake Ellens. Nicholas Erickson. Jesse Fernandez. Michael Fink. Nicholas Fiore. John Fournier. Chase Frary. Jonathan Gilman. Megan Gerard. Nathan Gruber. Michael Goodbranson. Eric Guo. Kendra Hahn. Zachariah Hales. Jordan Hatcher. Mitchell Havercroft. Daniel Heibel. Abigail Hendrick. Bryce Hilborn. Nathaniel Hoffman. Shui Hua. Tyler Humanick. Michael James. Austin Johnson. Daniel Jones. Philip Kazanowski. David Kavalauskas. Christopher Kimsey. Alexander Konicki. Connor Koss. Tyler Cracker. Andrew Cruzy. Anthony LaDuca. Juan Lamb. Ethan Lewis. Zachary Lobestall. Bradley Leffler. Chad Locker. Trevor Lohman. Emily Lowry. Wesley Luna. Malcolm McDonald. Kendra Marcaney. Dylan Matthews. Bo Matthews. Morgan McKee. Christian Malone. Andrew Mitchell. Rudy Morey. Cameron Muldowney. Samantha Murphy. Michael O'Connor. Colton Odom. Aiden Pantonja. Greg Pavelchuk. Joseph Peterson. Trey Pfeiffer. Alex Cordokas. Abby Rapson. Thomas Rittering. Joshua Robinson. Josephine Ryder. Joseph Samojadi. Kelly Schultz. Riley Seifert. Tessa Schaffer. Matthew Sherman. Jenna Sika. Tyler Smith. Dylan Speet. Caroline Spiteman. Nolan Stanko. Jenna Stolzman. Kaylee Stowe. Austin Taylor. Jordan Telgenhoff. Brianna Trumelli. Ryan Tran. Joe Trenshaw. Chase Tuttle. Zachary Took. Anthony Uriarty. Dean Van Elderen. Philip Branderberg. Hunter Vanderplo. Ruben Veen. Nicholas Veldema. Caleb Verbrugge. Michael Verwise. Joshua Vogley. Christian Volmers. Ryan Wolcott. Avery Ward. Connor Webster. Jacob Weezies. Catherine Waisman. Genevieve Wisby. Thomas Woodarczyk. Nick Zalewski. Please give one last round of applause to the undergraduate class of 2021. I couldn't have done it. Oh, I gotta go. Okay. All right, thank you all very much. We also have some graduate students this year who we will also be presenting with the ring. Cody Dean. Ryan DeMeester. Ghalam Imtiaz Hassan. Azakul Islam Ramon. Eric Hagan. Ryan Lubbers. Kelly Martin. And Samantha Spur. And if you would give one last round of applause to our graduate students from 2021. We are done.
take my notes? Let's do one more round of applause for these great graduates. So every year, this program is growing more and more in time because we're graduating more engineers. So it's a good problem to have. So your other son or your daughter, when they come here in a couple of years, will have double, and then we're actually looking at another room. So, however, I'll make it short. Honor society. So we have the honor societies that students who are achieving certain service and academic credentials can be member of. I have to say that for engineering students with the co-op and work and other things, it's a challenge. So with that, I would like to invite the honor students to be recognized. I'm going to call one group at a time. So the first group is the Frederick Myers Honor College members. If you are one of them, please stand up to be recognized. So let me say a couple of words before you sit down. A couple of words. On top of the engineering courses, they have to maintain grades. They have to take additional courses that will add to other skills. So communication skills, service, public, and so on. So it's really another package. If we're talking about engineer and our duty to the society, these are an example. These are examples of students who work through the college and maintain that. Very honored to have you. Thank you very much for your achievement. The second group I'm inviting to stand up is the members of Tau Beta Pi. I think it's the end of the day. I'm tired. Are they the same people or something? Great. Tau Beta Pi is by invitation. These are an honor national society. Very special to have it in your resume. These are the top academic and service type students. These are all great students. These are the model that would like to show. So huge achievement. It's not easy. We know that our exams are hard. It's not easy to maintain 5% or 3% of the top of the class, which is some requirement in some places. So great achievement, and please carry it on to your workplace. Congratulations. I'll continue to pick really good ones so I can show it to you. Outstanding Student of the Year. So for every program, we pick an outstanding student. I have to say we have outstanding group of students. Engineering is not easy. Is not an education that's kind of can glide through. You have seen the projects this morning, and you have seen and witnessed what's happening in weekends and other things to get through this degree. So it is an outstanding skill to actually complete the degree and finish it. However, we have to pick one. So we have to pick one outstanding student. And usually faculty discuss it, and we try to find a criteria. Academic is one, of course, but other than that, who will be the engineer that we want everybody to interact with that has something on the wall saying, this is the outstanding engineer of the year for this program. So this is a big thing. And we really put a lot of effort into that. And believe it or not, sometimes it's hard to pick because we have so many good to pick from. So the names I have are our choice. I know there are others that's great too. So I'd like to mention the name and the program, and would like to invite the president and the dean to come here to congratulate them and kind of help me pass the certificate. So the outstanding student of the year for the computer engineering program is Adam Montaggio. And we are all the same. First one. The outstanding student for the electrical engineering program is Katie Armstrong. The outstanding student for the mechanical engineering program is Maxwell Chimley. The outstanding student for product design and manufacturing engineering program is Chase Ferrari. And last but not least, the outstanding master engineering student is Jackson Pennick. He's not here. So if you stay with me for just two more minutes. So yeah, so we also pick the outstanding project of the year. So this year we have 26 projects, 26 outstanding projects. And as I have been repeating today, you have to pick one. So this is how the process goes. You vote, and your vote is, based on the outcome of the project, your view, and also we sit as faculty together and evaluate the technical component, and we combine all of that and pick one. Sometimes it comes as two. So kind of we call it people view and faculty view. So this year, the two came to be one. So that's great. The competition was hard that we have two honor mentioned that I'm going to say afterward, but some years actually we have two, but this time it came to be one. So the outstanding senior project for the year, and if you hear your name, you have to jump and then come here. The whole team, is DonorWorks Embedded Internet of Things. Congratulations. I'll mention the name quickly so you can run. John Gilman, Chad. Okay, give them afterward. Okay, great. So Paul will figure out how to give to you. So the owner mentioned two teams. When I mention your name, please stand up to be recognized. Team number 6 is a dual lane slab forming line. So please stand up. And the second honor mention is team number 8, which is GE Aviation, GE Memory Characterization System. Please stand up. Great, thank you very much. Sit down. So, I know we're trying to finish. This is a moment I'm going to look at the camera, because we have a faculty who is retiring. And I invited him to come, but he has something else happening at the same time. We are streaming, so he will be watching me now. So Charlie Standridge, a mark of this university, not just the school. So I was collecting information about Charlie, and then I got the staff to look for how many years he has been in Grand Valley. Then they came back and say 22 years. I said, no way. Let's go back. I think there's a mistake. It's only 22 years. I could not believe that. And I don't know who invented the retirement system. It's not a good system. Charlie is Charlie. You know, just talk to any faculty and staff. He's the one who knows how to get things done, for real. You know, who said that? Charlie did that. So he's a great faculty. He served as faculty, chair of multiple programs, director of School of Engineering, assistant dean. He has a lot of graduate students that graduated for him, many grants in research, including wind energy and others, a lot of articulations with other universities that he was a man behind the scene. So he was one of these faculty behind the scene administrator / faculty superman kind that can do all kind of things. So now I'm looking at the camera and say, thank you, Charlie. That was great run. I cannot believe it's only 22 years. Retirement, I want you to read the fine writing. You're still here, so you continue to reach. You'll continue to teach with us. It was my personal pleasure to work for you and with you. And best of luck in your retirement. And he will continue teaching with us undergrad and grad courses. And I will not let you go. Can you see? So before my concluding remarks, I would like to thank the staff who worked to make that happen. This is not an easy event, and we have to get a lot of approvals to get that happening. The team who had been working this event, and this is not an event, this is a week of events, have been working for at least 3 or 4 months. And the office team, the staff, the senior project faculty, and all the team have been working together to make it happen as smooth as it can be. To the point in the morning, they will get me the notes and say, I think we're perfect, just don't worry about it, I think we're great. We have the best team in the universe. So please say thank you to all the team who have been hiding in the back, and I'm not mentioning them because, so I don't forget. Thank you very much for a great event. We're almost done. My closing statement, and then the dean will do his closing statement. I started by saying skilled hand was well-trained, stronger, and can serve. Now, every one of us on the other side here, you have that to remind you. You are the skilled hand. We need you. Everybody here needs you. We need to move forward to the next step. My closing remarks looks like that. If I have one flashlight and I aim it on the wall, you can see a little bit. If 143 aim the same flashlight on the wall will be very bright and everybody can see it. This is great. If this 143 synchronize their light and turn this flashlight into laser, it will get through this wall. So, working hand cannot work alone. Flashlight will be nice and to see if you're camping, but laser, and this is a fact, laser beam can reach the moon. So just remember that. You are skilled, and you will be more skilled with another hand. So it's team. Congratulations, and thank you very much.
As you can tell, this ceremony is very scripted, with one exception. The last element says, and the dean steps up and says a few wise remarks. Anybody that knows me, that few? Wise? We'll try and keep it brief, though. each time we have this ceremony, I'm always amazed by the interconnectedness. So you heard earlier about a career built on things that broke. And sometimes those are challenges. Sometimes they're opportunities. My career started when the oh crap moment, I'll keep it clean, the oh crap moment happened and they broke it. And then they needed somebody to figure out why. That's when my phone rang. So it's an opportunity to learn. It's not usually a failure. It really is, okay, now we need to figure out what's going on and how do we go from here. I also am always amazed when I look at the accomplishments of the students that are graduating and joining the profession. We have a newsletter for the college. And initially it was an annual newsletter, kind of that annual report sort of thing. There were so many good things going on that we made it biannual. And then we made it quarterly. Now we produce that monthly. And we get all across our partners, we get feedback about how impressive the work that's going on is. And it's the work of the students and the faculty and the staff that make this happen. Now, what the students don't realize is behind the scenes on that newsletter, we're really watching what's going on. Okay? Most of the students have met me once or twice. You know, usually if they're thinking about coming to Grand Valley, I talk to some of them and their parents. Might see me at an orientation. Unfortunately, I'm kind of the principal, so when they stub their toe, when the professional societies need money, that's when, you know, they show up in the dean's office kind of thing. But we really do have a sense of what's going on behind the scenes. One of those quiet folks that just kind of makes things happen, right? So we do the quarterly, or the monthly now, newsletter, and there are as many items that don't go in as do go in. And as often as not, it's because the students are too humble and they don't want to be singled out. So just a couple observations about this class. So engineering is supposedly a four-year program of study. And some of the folks sitting over there did it in 4. Some of them took 5 or 6. Some of our non-traditional students, 8 or 9 or 10. So you get to look around and figure out for yourselves, okay, you have a sense, but who was here 4 years and who was your 8 or 9 or 10 to get here? It's not frequently starting at a community college or someplace else, non-traditional student that took a little bit more circuitous route to get here. Lots of amazing things happening along the way. So I'll do a puzzler for the class. I think only one student in the class knows the answer to this. One of the things that didn't make it to the newsletter, as an example, one of our companies that co-ops our students works with J&J, Johnson & Johnson. You've heard a lot about their vaccines and whatnot these days, right? When they do major projects, if there's somebody that really shines on that project, they do kind of an employee of the month, if you will. For the first time in their history, it was a team, well, they do a lot of teams with vendors and people that support them. For the first time in their history, they named somebody who wasn't a J&J employee as the employee of the month. And it wasn't until after they did that that they were informed this is a co-op student. Now you have to figure out who that is, okay? That's one of the items that didn't make it to the newsletter. So along the way in this journey, we've congratulated them, but it's rarely an individual journey. Forget rarely, it's never an individual journey. And there are a lot of people that contributed. We heard about the faculty, we heard about the staff, we heard about the co-op employers. Well, generally, and especially this year, with what we've all been through, the role of your family supporters is huge. Those folks that took 4 or 5 or 6, and the parents didn't see you on the weekends, and they didn't get that visit they were hoping for, and the spouse who was being supportive and taking care of things on the home front while you couldn't be there, that sort of thing. That is hugely important and always will be in your life. So both for the folks that are in the room, and we have several hundred others that are watching from other places, I invite the students that are entering the profession to stand up, join me, give them a round of thank you for all they've done to help support you. And even with COVID, when you go home, you can give them a hug. All right, you have my permission. With that, I'm about the last thing except a little bit of a video presentation that'll be rolling as you depart. Enjoy the evening and enjoy your lives and your careers.
Thank you.